Surface areas and volumes, exercise 13.1. So before going to the exercise, let us revise these important formulas which you already have learned in grade 9. That is TSA of a cuboid 2 into LB plus BH plus LH, TSA of cube 6L square, CSA of cylinder 2 pi RH, CSA of cone pi RL, CSA of sphere 4 pi r square and CSA of hemisphere 2 pi r square. TSA means total surface area and CSA curved surface area, that you already know it. Next, volume of cuboid LBH, L into B into H, volume of cube L cube, volume of cylinder pi r square H, volume of cone 1 by 3 pi r square H, volume of sphere 4 by 3 pi r cube and volume of hemisphere 2 by 3 pi r cube. So in the exercise 13.1, that volume part is not there, only the surface area part is there. So let us move on to exercise 13.1. Question number 1. Two cubes, each of volume 64 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. So let us first figure out the figure first. So two cubes placed joined together. So it is given that the volume of each cube is 64 centimeter cube. So with that we can find the side. Volume of one cube equal to 64 centimeter cube, that is a cube. So A, that is the edge of the cube, will be cube root of 64, which is equal to 4. Now the resulting cuboid. So let us say the dimension. What are the dimensions of this cuboid? So here you can see the length part became double, but width and height remains the same. So length equal to 4 plus 4, 8. Breadth equal to 4 and height equal to 4. Now CSA of a cuboid 2 into LB plus BH plus LH. So let us substitute the values of LB and H in that and solve it. So the answer we will get is 160 centimeters square. That is the surface area of the resulting cuboid. Shall we go on to the next question? Question number 2. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 30 centimeter. Find the inner surface area of the vessel. So first we need to draw the figure. What is the figure? A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. See, so one hollow sphere and on the top of that, mounted by means top of that one cylinder. And the dimensions are given here. It is given that the diameter is 14, so radius will become 7, and it is given that the total height of the vessel, which is equal to 13, that means the height of the cylinder, that will be 13 minus 7, because this part is 7, this is 7. So we have to subtract that. So 13 minus 7, 6 centimeter will be the height of the cylinder. Now radius of the cylinder as well as the hemisphere both have the same radius, which is equal to 7 centimeter, and height of the cylinder is equal to 6 centimeter. Now total inner surface area of the vessel, that is what we have to find, which is equal to inner surface area of the hemisphere plus inner surface area of the cylinder. So let us apply the formula here. It is 2 pi r square plus 2 pi rh. So both have the same radius. So pi, of course, the same value. So the 2 pi r we can take it out, which is equal to, which is common. So the simplification will be a little more easy for you. So 2 pi r into r plus h. Now let us substitute the values. So pi is 22 by 7. So the 7 will get cut. So we will get 2 into 22 into 13. On simplification, we will get the answer as 572 centimeters square. That is the inner surface area of the vessel. Next question. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy 15.5 centimeter. Find the total surface area of the toy. So it's made up of a cone and a hemisphere. So let us see the figure. So you can see that there is a hemisphere and on the top mounted on a hemisphere. So cone is mounted on a hemisphere. And total height of the toy given, radius given. Radius equal to 3.5 and total height is 15.5 centimeter. So what will be the height of the cone? Height of the cone will be 15.5 minus this 3.5, this radius we have to subtract. So it will be 12 centimeter. Now total surface area of the toy, of course it will be the CSA of hemisphere plus CSA of cone. So just apply the formula. CS of a hemisphere is 2 pi r square and CSA for cone is pi r L. So here we know r, but we don't know the L. L means the slant height of the cone. So we have to find out the slant height L. That is L square equal to r square plus h square. R and h it's given. So let us substitute the values. So we will get L equal to 12.5 centimeter. Now let us substitute the values in the equation. 2 pi r square plus pi r L. So in this pi and r are common because both have the same radius. So pi r into 2r plus L and substitute the values. So on simplification, we will get it is 11. 22 by 2 is 11. 11 into 19.5, which is equal to 214.5 centimeters square. That is the total surface area of the toy. Now let us move on to the next question. Question number 4. A cubical block of side 7 centimeter is surmounted by a hemisphere. Surmounted means it's put up down. What is the greatest diameter of the hemisphere can have? So let us see. A cube, and on the top of the cube, the top face, in the top face, a hemisphere surmounted by a hemisphere. So a hemisphere is kept on the top with its base circle is on the face of the top face of the cube. And the question is, what is the greatest diameter the hemisphere can have? So it's very clear from this picture. What will be the greatest diameter? It will be the length of the cube. No, otherwise this this hemisphere will go out of this surface. No. So the greatest diameter of the hemisphere can have is length of side of cube, which is equal to 7 centimeter. Now we need to find the surface area of the solid. the solid surface area. So how we will find that? Surface area of the solid equal to surface area, the curved surface area of cube plus curved surface area of the hemisphere minus area of base of hemisphere. That means this part we have to remove. The base of that circular part of that hemisphere, that we have to remove. Then only we will get the remaining area. So 6L square plus 2 pi r square minus pi r square, and 2 pi r square minus pi r square is pi r square. So it is equal to 6L square plus pi r square. Now L we know, R we know, so we just have to apply the values, and on simplification, what we will get? So it is 6 into 49 is 294 plus 77 by 2, that is 294 plus 38.5, which is equal to 332.5 centimeters square. So here only one thing you have to remember, that when you find the surface area of the solid, it is surmounted here. So this circular part of this hemisphere is kept down on the face of the cube. So that part area no need to count. So you need to subtract that. Just imagine that you cut a lemon and kept it on the top of a square or on a cube. So that part is in touch with the bottom part of the lemon, will be in touch with the cube now. So that area no need to count. Only this surface, this area of the hemisphere need to be counted. That is why we are subtracting this area of the circular part. Is it clear? Now let us move on to the next question. Question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Depression means it is cut to inside of the one cubical wooden block there, and from that it is carved out. A hemispherical is carved out, and that wood is taken out. So that is the depression. Let us see the figure. So here you can see it's a cubical wood, a wooden block, and it is carved inside in the shape of a hemisphere. So that means this colored part, no, that is inside part. That part, the wood is carved out. So you have to understand that. Okay, now we have to find the surface area of the remaining solid. So let us see. Diameter of the hemisphere is edge of the cube, which is equal to L. Radius will be then what? L by 2. Now surface area of the remaining solid equal to surface area of the cube plus inner surface area of the hemisphere minus area of circular part on the top of hemisphere. Again, this top part we have to subtract that part, because it is depression of whole, it is what to say, it is depression cut out, no, cut out. So that part area we have to remove. So it will be 6L square plus 2 pi r square minus pi r square. It is somewhat similar to the previous question, but in the previous question, the hemisphere was surmounted. It is put up down. It is here. It is curved inside the cube. So that part, top circular part, has to be removed. So just apply the formula here. We cannot take anything common. So just apply. So R means L by 2. So pi into L by 2 into L by 2, which will give you 6L square plus pi L square by 4. So L square is common. So L square into 6 plus pi by 4. That is that much. What will be the unit is not given. It is in terms of L. So this is the area of the remaining solid. Is it clear? Now question number 6. A medicinal capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Find its surface area. So capsule means we all, everybody know what's a capsule. We all have it. So a tiny capsule. That is why the measures is given in terms of millimeter. It's very, very small, you know. So let us find the surface area. So the surface area of the capsule is CSA, curved surface area of the cylinder, plus curved surface area of two hemisphere on both the end. No, see here, two hemispheres are there. So we have to take the area of these two hemisphere plus the cylinder. So instead of taking 2 into surface area of hemisphere, 2 hemisphere will make it to 1 sphere. So we can change the equation to, it will become what then? So here the radius of this hemisphere is equal to diameter is 5 millimeter. So this is 5 by 2. Then the height of the cylinder will be, the total length is 14 millimeter. So the length of the cylinder alone will be 14 minus 2, half of 5, no, 5 by 2, 5 by 2, both side will go. So 14 minus 5 equal to 9. So TSA of the capsule is CSA of cylinder plus CSA of one sphere. Instead of taking 2 into CSA of hemisphere, we can find CSA of one sphere. That formula we can apply. So radius is 5 by 2 and height is 9. And let us substitute the values. The cylinder, the CSA of cylinder is 2 pi RH plus CSA of sphere, it is equal to 4 pi r square. So here 2 pi r is common, that we can take out. So 2 pi r into h plus 2r. So substitute the values there, and on simplification we will get 22 into 5, which is equal to 110 by 7 into 14, and 7 and 14 we can cut. So the area is 220 millimeter square. Question number 7. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. So let us draw the figure first. So tent is in the shape of a cylinder surmounted by a conical top, and the dimensions are given. The diameter of the cylindrical part, the height and diameter are 2.1 and 4 meter. That means radius is 2 and the height of the cylinder is cylindrical part is 2.1 and the slant height of the conical part is 2.8 meter. Now area of the canvas is very clear. It is the CSA of cone plus CSA of cylinder. Now radius of the cone and the radius of cylinder both are the same, which is equal to 2 meter, and height of the cylinder is 2.1 meter. Now slant height of the cone, that also given 2.8 meter. Now area of the canvas is equal to CSA of a cone, that is pi RL, plus CSA of cylinder 2 pi RH. So here pi r is common. So pi r into L plus 2h, just substitute the values and simplify. So we will get 44 by 7 into 2.8 plus 4.2, which will give 7, 7, 7 get cancelled. So the area is 44 meters square. Now we have to find the cost of the canvas at the rate of rupees 500. So just have to multiply with the money, that's all. So cost of the canvas will be 44 into 500, which is equal to rupees 22,000. Not that here it is given base of the tent will not be covered, so that we already know. So commonly we won't cover, no. So that is it. So the amount is rupees 22,000. Now let us move on to the next one. From a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, a conical cavity of the same height and same diameter is hollowed out. Find the total surface of the remaining solid. So let us see the figure. First it is cylinder. See, from the cylinder, a conical part is conical cavity is hollowed out. So cone inside. So here the diameter is 1.4, so radius is 0.7 and the height of the cylinder is 2.4. Now we have to find TSA of the remaining part is equal to base area of cylinder plus CSA of cylinder plus CSA of cone. This base area of the cylinder also we have to find. So it will be radius of the cone is 0, cone and cylinder is 0.7, height is 2.4, and we have to find the slant height of the cone. So r square plus h square, on substituting the values, we will get it as 2.5 centimeter. Why we are taking this base? Because CSA of the cylinder means only this curved surface area only will come, but this cone is hollowed out, no, so base is there of the here base of the cylinder is there, that is why we are finding the area of that part also. So slant height also we got now. So TSA of the remaining part is equal to pi r square, that is the base area. From the base area little bit part is taken out, no, so the remaining part plus 2 pi rh plus pi rl. So substitute the value. So pi r is common, so pi r into r plus 2h plus l. So substitute the values and simplify. So it will be 22 by 10. So we can take it as 2.2, and on adding that decimals we will get 2.2 into 8, which is equal to 17.6 centimeter square. That is the remaining part of the cylinder. So it's given that solid cylinder is given. Okay, next question. I think that is the last question of this exercise. Question 9. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder. Let us see the figure. So you can see on top and bottom part, two hemisphere are scooped out. So the height of the cylinder given and the base of radius, base radius also given. Find the total surface area of the article. So it's very simple question. So area means we have to find the area of the two hemisphere plus area of the cylinder. So instead of adding two areas of hemisphere, we can find one sphere area. So CSA for one sphere plus CSA of cylinder, and radius r equal to 3.5, height of the cylinder h equal to 10 centimeter, and let us apply the formula 4 pi r square plus 2 pi r h. and here what is common? 2 pi r is common. So 2 pi r into 2r plus h. So substitute the values and simplify. 2 will go, 7 will go, inside 2 will go. So 22 into 17, which is equal to 374 centimeter square. That is the total surface area of the article. And that is the end of this exercise. Thank you. Meet you with next exercise. Bye.